Hello, hello. In this video, we'll be looking at systems of linear equations. So you may recall from some previous work that a linear equation can be written in the form ax plus by equals c. So we might have a multiple of x, a multiple of y, and the sum is going to be equal to some constant. Now, in some situations, these multiples may just be 1, so this could look like x plus y equals 3. Or we may have coefficients other than 1, so it could be 2x plus 3y equals 6. Uh, It's also common to write a linear equation in the slope-intercept form. So that looks like y equals mx plus b, where m is the slope and b is the y-intercept. So in this section, we're looking at systems of linear equations, which could be two or more linear equations. For the purposes of this video, and we'll just be looking at systems that include two linear equations. And we're looking to see if we can find solutions to these systems. So let's just start with an example, and then I'll show you what the possibilities are for solutions for systems of linear equations. So our first system looks like this. We have the equation x plus y equals 2, and a second equation y, I'm sorry, x minus y equals 5. One way to look for solutions for a system is to graph the equations together on one set of axes. And so I'm going to do that. And we're going to look to see if the graphs intersect, and if so, where. And so remember, we have a couple of strategies for graphing linear equations. One graphing strategy is always to make a table of values. And so for the first equation here, we have x plus y equals 2. I'm going to pick a few values. And so if I have negative 2 plus some number equals positive 2. So that would be 4. So if you want to think about this, negative 2 plus y equals 2, I could add 2 to both sides, and I would end up with y equals 4. For the next number, negative 1 plus some number is 2. So negative 1 plus some number is 2. So adding 1 to both sides, I would see that the solution is that y must equal 3. And then 0 plus some number is 2. That would be 2. And 1 plus some number is 2 would be 1. And 2 plus some number is 2. That would be 0. So here I have 5 ordered pairs. That's more than enough to graph this equation. I'll start with the point negative 2, 4, negative 1, 3, 0, 2, 1, 1, and 2, 0. And I'll just connect those with a straight edge and cap them with arrows to show that that goes on and on forever, and label this as x plus y equals 2. We can also rearrange this into slope-intercept form. That's what I'll do for the second one. I'm going to start by subtracting x from both sides. So I'll end up with negative y equals 5 minus x. And I want to get rid of this negative, so I can divide each term by negative 1, which essentially just changes the sign of each term. This becomes y, this becomes negative 5, and positive x. And I'm just going to swap places for these two terms and say that's y equals x and minus 5. So I have a slope of positive 1 and a y-intercept of negative 5. 1, 2, 3, 4, 5. So here's the point 0, negative 5. That's my y-intercept. Since I have a slope of 1, That's a rise over 1, where both the rise and the run are 1. So over 1, up 1, over 1, up 1, and keep going, 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 and then connect these points. And here's my second line. This is the line x minus y equals 5. So these two lines have a single point in common, and that's right here. This is where they intersect. This point is the solution, the only solution to this system of linear equations. It's an ordered pair with an x-coordinate and a y-coordinate, and this ordered pair, these values of x and y, will satisfy both of these equations. And when I say satisfy, I mean when we plug in the x value and the y value, we'll end up with two true statements. Now, one of the downsides to graphing by hand is that I may not get great results, but it looks like the x-coordinate for this point is between 3 and 4, and the y-coordinate is between -1 and -2. So in order to find exact values, I'm going to use my calculator. So I have my TI-84 handy, and let me show you the strategy here. So it's kind of faded on my calculator, but the first button here is a y equals. I've actually got some stuff in there I need to clear out. So if I want to use this feature of my calculator, I need to have these solve for y. So since these are linear, they both need to be in that y equals mx plus b format. So the first equation here, x plus y equals 2, I'm going to subtract x from both sides, and I'll have y equals -x plus 2, or you could leave it as 2 minus x. I'll just show you. So this button allows me to insert a variable, so I'll say 2 minus x. And we already put the other one in slope-intercept form. It was x minus 5, so x minus 5. So I have both of these guys written into my y equals, I guess we'll say screen. So next I want to go and let's just see what happens if I hit graph now. We're not seeing anything. That's likely because I need to adjust my window. So that's the second key from the left here. So I'm going to change my minimum to -5, my maximum to +5, and then sort of scale 0. What that means in terms of my handwritten graph is I'm going from -5 to +5 on my x-axis. So the x minimum is -5, x max is +5. And the 1 means I want to put a tick mark for every 1 unit. So that's much like what I did in my hand-drawn graph. For the y minimum, I'll make that -5 and the max +5, and also use a y scale of 1. Let's do this again. And we're seeing something very similar. Now I have an extra dot here, and that is because I have another option turned on. Let me just take care of that. So I'm going to go back to my graph, and now we should just see our two lines. So the calculator, the TI-84, has a feature which allows us to find the coordinates for this point of intersection. We will use our calculation menu. So that's written in blue above this fourth key. To access it, I'll hit the second key and then calculations. And then the fifth option is intersect. So I'll hit 5. And honestly, you can just hit enter 3 times, and we'll find that the x-coordinate is 3.5 and the y-coordinate is -1.5. And really that matches up pretty well with the drawing I had. I had estimated that this was between 3 and 4. It turns out it's 3.5, and that the y-coordinate was between -1 and -2, and it turns out it is actually -1.5. So this is the solution to this system of linear equations. It's the ordered pair, the coordinates for where the two lines intersect. Now, Another way to think about this is that, and I mentioned this before, is that this ordered pair will satisfy both of these equations. So when I take x plus y equals 2, and when I replace the x with 3.5 and the y with negative 1.5, I'll have 3.5 plus negative 1.5 equals 2. And I'm just verifying to see if this is true. 3.5 minus 1.5, sure enough, is 2. And in the second equation, x minus y equals 5, that would be 3.5 minus negative 1.5. I'm checking to see if that does in fact equal 5. And when you're subtracting a negative, that's the same as just adding the two values. And so, sure enough, 5 does equal 5. So this ordered pair will give me true statements for both of these linear equations when I substitute in the x value and the y value. All right, so in the next video, I'll show you some other possibilities for the solution sets for linear equations.